Questions 11 through 20 on the 2009 grade 10 AMC 10B. How many 7-digit palindromes, numbers that read the same backward and forward, can be formed using the digits 2233555? Well, let's play around with this, see what we get. Let's say you put the 2's on opposite ends and put the 3's in the middle. Then the 5's have to go in the middle like that. So that's one scenario. The other scenario is if you're going to keep the 2's on the other end, but switch the 5's. So 5 go here, 5 goes there, and the 3's go there. And the 5 again is in the middle. And I think that does it for the 2's with regard to placing 2's at the opposite end. Now what I'll do is I'll place the 3 at the opposite end. Put the 2's inside, and very similar to before, the 3 5's go in the middle. And then I can do the exact same thing by switching 5's with the 2's, and put the 2's there, and the 5 goes in the middle. So it seems like this is going to be in such a way that the 5 is always going to be in the middle, since there's nowhere else that 5 can go. Now, the only other thing, of course, is 5's on the other end, each end. And then the 5 goes in the middle. So now we just have to fiddle around with the 2's and the 3's. That's one way. And then, of course, 3's and 2's like that. And this is it. This is the only 6 possible palindromes that we can make with these numbers. So number 11, the answer is A. Distinct points A, B, C, and D lie on a line with AB equal to BC equal to CD equal to 1. Points E and F lie on a second line parallel to the first, with EF equal to 1. A triangle with a positive area has 3 of the 6 points as its vertices. How many possible values are there for the area of the triangle? Let's draw our first line, and let's draw another line parallel, like that. And let's label these points. So A, B, C, D, but they're all equal. So approximately here and approximately there. So A, B, C, like that. So these are all equal, right? I'm just drawing a little line there. I don't know if that helps, but they're all equal to 1. Maybe I'll just write the number 1. That might be a little bit better, like that. And then the second line has EF. Now, they don't tell us where EF is. So if they don't tell us, then perhaps it doesn't matter. So I'll just put EF anywhere. E and F, like that. And that is also equal to 1. And then what they're doing is they're creating triangles. So the first thing I want to do is very quickly write out all the different triangles. So, for example, ABE, ACE, ADE, like that. So I'll write them all out. And then now let's discuss what would happen if we were to create triangles. So ABE, it's this guy right here, right? Now what is the area? The area, I'll just do the first few, and then we can sort of just fill them all in really quickly. 1/2 base times height. Well, the base is 1, and the height is right there. And the height is always going to be the same for all of these. Since these two lines are parallel, these heights will be always the same. And therefore, I can just call the height something. So I'll just call the height H. And since it doesn't really matter what H is, I'll just give it a value of 1. Makes it easier. Why make it complicated, right? Why introduce more variables to make it more difficult to understand? So the first one, which was ABE, which was this triangle right here, if you were to do 1/2 base times height, it would be 1/2 base, which is 1, times height, which is 1, which is 1/2. So I'll put 1/2 right there. And I'll just do a few more. ACE, so A all the way to C and then E. This guy right here, 1/2 base times height, would be 1/2 2 times 1, which is equal to 1. And then ADE would be 1/2 base times height, which is 1/2 3 times 1, which is 3/2. And in a very similar way, you can calculate all of these very quickly. This will be 1/2, this will be 1, this will be 1/2. This will be a half. And then we have 1, 3 over 2 for this guy. BCF will be a half. I'm just doing this because I don't think you want to hear me go through every single one. I don't think that's even necessary. And then all of these guys are going to be a half. So what they're asking, very important, is how many possible values are there for the area of the triangle? So different values. Well, it can be either a half, a 1, 3 over 2, and the rest are all the same. Now, remember, these values I got because I let h equal to 1. But obviously it could be anything else. The key is how many different values. And there will only be 3 different values, as I have illustrated here. So number 12, the answer is A. As shown below, convex pentagon ABCD has sides AB equal to 3, BC equals 4, and CD equals 6. DE is 3, and EA is 7. The pentagon is originally positioned in the plane with vertex A at the origin and vertex B on the positive x-axis. The pentagon is then rolled clockwise to the right along the x-axis. Which side will touch the point x equals 2009 on the x-axis? This question basically saying, originally, of course, you have AB on the x-axis. Then as it's rolled, the next one, BC, will land on the x-axis. And then eventually, the next one, DC, will land on the x-axis. Then DE will land, and then finally EA will land. And they're saying if you keep doing this, when you get to x equals 2009, what segment will be on the x-axis? So the lengths of each side is essentially what's going to help us figure this out. So the lengths are 3, 4, 6, 3, and then 7. And then it keeps repeating, right? 3, 4, 6, 3, 7. It's the same shape that's going to be rolled over and over. Now, if you add these guys up, that is 23, if my addition is correct. And therefore, we're just going to have multiples of 23. Eventually, you get to 2009. So the first thing I want to do is figure out, is 2009 divisible by 23? And the answer is no, it's not. It's 87 remainder 8. So what that means is that this shape rolls 87 times and then lands exactly where it is, but then there's another 8. Okay, that means that 3 and then 4 and then the 1 spot will be right there. I'll draw a little arrow there. Does that make sense? Because we've got to account for another 8, and that's only possible if you keep going. And A to B gives you another 3 units, B to C gives you another 4, and then that additional unit will be on line DC, or CD. And therefore, number 13, the answer is C. On Monday, Millie puts a quart of seeds, 25 of which are millet, into a bird feeder. On each successive day, she adds another quart for the same mix of seeds without removing any seeds that are left. Each day, the birds eat only 25% of the millet in the feeder, but they eat all of the other seeds. On which day, just after Millie has placed the seeds, will the birds find that more than half the seeds in the feeder are millet? I think millet is a type of grass, but I'm no expert on birdseed. So here we go. We got Monday, and then the answer choices go all the way to Saturday, so I'll just write until Saturday, and then let's see what happens. So on Monday, we have millet, and then we have, I guess, the regular bird seed. They don't really give a name for the other type of seed. They just say other seeds. All right, so on Monday, we start off with, let's just give a number. It'll make it easier. Let's say that each quart has 100 seeds. So on Monday, we add 100, right? But 25% of them are millet. So the other 75 are the regular. So the next day, what happens is the birds will only eat 25% of the millet. So we are down to 18.75 since they ate only 25%. And they eat all the regular, so we're down to 0. And then now, Now we add a full batch of 100 seeds, and we're going to add, just as before, another 25 of the millet and another 75 of the regular seeds. So the millet total is 43 approximately, and the regular seed total is 75. Don't worry about the decimal points. I mean, it's not going to make a big difference. And then they eat 25% of this, so we're down to approximately 32. And then this is down to 0 because they eat all of those. And again, we repeat the same process. We add 25, and this becomes approximately 57. And we add 75, and this becomes 75, of course. Again, we add 25, but then this number is reduced by 25%. So it becomes approximately 43. And then we add 25, and that becomes 68. This drops down to 0, but then we add 75 and goes back up to 75. Now, we forgot about the question I did, that we have to figure out when is the millet more than half. Well, so far it's 68, and the regular seeds is 75, so we have not reached that point yet, but maybe the next one we will. So the 68 has to decrease by 25%, and if it does, it drops down to approximately 51. And then, of course, we add 25 fresh new millet. That brings it up to about 76. This number is eaten completely, and then, of course, we add 75 fresh new seeds, and that becomes 75. At this point, there's 76 millet and 75 regular seed, and at this point, more than half of the seeds in the feeder are millet. So that happens on Friday. So number 14, the answer is D. When a bucket is 2/3 full of water, the bucket and water weigh A kilograms. When the bucket is 1/2 full of water, the total weight is B kilograms. In terms of A and B, what is the total weight in kilograms when the bucket is full of water? So 2/3 of W, I'll let W represent the total amount of water and when the bucket is full. 2/3 of that plus the bucket is equal to A. And then 1/2 of W plus the bucket is equal to B. So we have to figure out W plus B. That is our goal. So since we have to figure out W plus B, I'm assuming we have to manipulate these two equations, since that's the only thing we have to do. All right. The first thing I'm going to do is subtract them. So that means 2/3 W minus 1/2 W. The B's cancel and I get A minus B. So this gives me 2/3 minus 1/2. So 1/6 W. This should be W there. Is A minus B. And then the other thing I can do, of course, with these two equations is substitute this guy into either of them, and that should work. Help us isolate for one variable at least. So it's 2/3 times W, and W looks like it's A minus B times 6 from this right here, and that plus B is equal to 8. So isolating for B, this looks like, let's see here, 2 times 6 is 12, 12 divided by 3 is 4. So B looks like A minus 4 times A minus B. Okay, I think we have enough here to figure out W plus B. W plus B is going to be, from here, W is 6 times A minus B, correct? And then B is right there, so that is A minus 4 times A minus B. All right, let's see what we get here. So we got 6A minus 6B plus A minus 4A plus 4B. And this looks like 2A plus 3A minus 2B. So there you go. So number 15, the answer is E. Points A and C lie on a circle centered at O. Each of BA and BC are tangent to the circle, and ABC is equilateral. The circle intersects BO at D. What is BD over BO? Let's draw a little diagram first. And I will label this diagram. So we have points A here and C, and then we have O obviously here. And then our point at the very top is going to be B right here. And this ABC, as they say, is equilateral triangle, and it looks like that. And now we have to start labeling things. So I will label this X from A to O. That is the radius of the circle. And then since BA is tangent, this is going to be a 90 degrees right there. And we have to figure out this ratio, which is BD over BO. And let's talk about that. BD is where? Well, first and foremost, what is D? The circle intersects BO at D. So D is right here approximately at this point. So BD over BO. Well, what's interesting is that BD can be written in the form of BO as follows. BD is really BO minus the radius, right? If you look at the graph, if you have BO from there to there, and then R is from here to here, if you subtract that, you get just BD. And this is over BO. So this becomes 1 minus R over BO like this. So if we can figure this out, we are done with our question. And the good news is we can do that pretty quickly. How is by looking entirely at this triangle right here, which is triangle BAO. And that triangle, you'll notice that the angles will help us greatly. Since ABC was equilateral, this is 60 degrees. But this is 30, since that BO chops it in half, chops the angle in half. And then this is 90, since that was a tangent line, and therefore this must be 60, right? So that is a 30, 60, 90 triangle. And the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. So if you look at just the ratio, R over BO is 1 over 2. And that's it. So this is a half. So number 16, the answer is B. 5 unit squares are arranged in the coordinate plane as shown with the lower left corner at the origin. The slanted line extending from A0 to 3, 3 divides the entire region into 2 regions of equal area. What is A? So each of these unit squares has an area of 1 times 1, right? Which is of course 1. So 5 of them would basically be a total area of 5. Now if you make this line and you chop it into 2 equal area regions, then each of those has an area of 2.5. So the area of the shaded region, AS, is equal to 2.5. Now, one thing I immediately notice is that if you draw a triangle, for example right here, this guy, like that, you will notice that that will help us out greatly to figure out the area of the shaded region in terms of A. How so? Well, that triangle is 1/2 base times height. The base will be, this is 3, right? So the base will be 3 minus A, and the height is just 3. Now, that is similar in comparison to the area of the shaded region. How? It's the area of the shaded region plus 1 unit square, this guy right here. And that 1 unit square has an area of 1. So this is my relationship. This will allow me to figure out A. So AS is 2.5, and we have 1. So I'm putting decimals again. Let's put this into fractions. That's 5 over 2 plus 1, so 7 over 2 is 1/2 times 3 minus A times 3, like that. So if you get rid of the halves, this will become 3 minus A is equal to 7 over 3. Or we can just expand it instead of multiplying by fractions and all that. If we just expand it, we get 9 minus 3a is equal to 7, and therefore 9 minus 7 is equal to 3a, and therefore a is equal to 2 over 3. So therefore 17, the answer is C. Rectangle ABCD has AB equal to 8, BC is 6, M is the midpoint of diagonal AC, and E is on AB with ME perpendicular to AC. What is the area of AME? Let's draw a diagram. So here we go. And let's label this now. We have A here, B, C, and D. And then M was right here. It's the midpoint of that diagonal, and E is here. And it creates a right angle because it's perpendicular. And they have told us that AB is 8 and that BC is 6, and this is a rectangle. So what are we trying to figure out here? We have to figure out the area of AME, okay? Well, the first thing I will try to do is figure out AC, because I'm going to need to know that value. AC squared is 8 squared plus 6 squared, 64 plus 36, which is 100, and therefore AC is 10. And since M is the midpoint, that means that AM is got to be equal to 5. So the area of AME is 1/2 base times height. I can use AM as the base and ME as the height. And AM I just figured out was 5. So if I can figure out ME, then I'll be done with my question. How do I figure out ME? Well, we are going to use similar triangles. I'll let this angle here be theta, and therefore this is 90 minus theta. And similarly, in the big triangle, this whole thing right here, ABC, we have very similar angles, the same angles actually, theta, 90, and this angle, which is 90 minus theta. So that means that triangle AME is similar to triangle ABC. And we can use the ratio of the sides. So that means that AM over ME is equal to 8 over 6. And AM we just figured out was 5, so this just becomes 5 over ME is equal to 8 over 6. So that means 30 over 8 is equal to ME. And we can reduce that a little bit, 15 over 4. So there we go. Put that into here, and that will allow me to solve. This will become, let's see here, 75 over 8. Yeah. And I think that is in lowest terms. So number 18, the answer is D. A particular 12-hour clock displays the hour and minute of a day. Unfortunately, when it is supposed to display a 1, it mistakenly displays a 9. For example, when it is 1:16 p.m., the clock incorrectly shows 9:96 p.m. What fraction of the day will the clock show the correct time? This question, I don't know how much of a confusion it caused people, but here's my sort of opinion. I always thought that if you have a clock, it starts at 00, right? And then it goes to 11:59 p.m. Okay? And then once it turns 12, it will go back to 0000. But that's not the way they're doing it in this question. They're doing it as follows. They're saying the clock starts at 1:00 and it goes till 12:59. Like that. And then after 12:59, it goes back to 1:00. Does that make sense? This is how they're doing this question, and that's fine, but I wish they had been a little bit more specific, because they're saying 12-hour digital clock, and the digital clock I have or had in the past was like that. So anyhow, that is, it's a math contest, and you're going to get these kinds of questions sometimes where there's just a little bit of a discrepancy. The only thing that will happen is that you'll get an answer that's not one of the answer choices, hopefully. And then you just have to do it in the other way. It just makes the question a little bit longer. So here we go. When we start at 1, like that, we're going to make a list of incorrect and correct, like this. So it's incorrect whenever there's a 1, right? So this whole thing will be incorrect. Any possible number that you put in there will be incorrect because this 1 won't show as a 1, it'll show as a 9. So all 60 out of 60 minutes will be incorrect. So correct is 0. All right, this will make more sense as we go along. The next hour is 2 something, right? 2 something, we don't know. And not all of those will be incorrect, only a few. If it's 2:01, if it's anything from 2:10 to 2:19, because all those include 1, 2:21, 2:31, 2:41, and 2:51. Those will all be incorrect. So how many minutes are those? 1, 2, 3, 4, 5, and 10, 15. So 15 of those 60 minutes will be incorrect, and the remaining 45 over 60 will be correct. All right? So far, so good. Nothing confusing, hopefully, so far. Now we continue with this. Now the good news is for 3, 4, 5, 6, 7, 8, and 9, it's the exact same scenario as this right here. And then we get to 10, 11, and 12. All of these are going to be wrong. Every single one. Why? Because there's a 1 in the hour section of it. So it doesn't matter what goes after it. All of them are going to be wrong. So all 60 out of 60 minutes will be incorrectly displayed like that. So correctly displayed will be 0, 0, 0. So this is the calculation. Now we have to figure out the probability, or fraction rather. Same thing, I think. Well, that fraction will be the total, which is 12 times 60, right? 12 hours, and each hour has 60 minutes. Now we have to count the correct. Well, the correct is just these guys right here, because the other ones are zeros. So how many of those? 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 45. That is my fraction. So let's see, in lowest terms, this looks like 2 over 3 times 3 over 4. And that's 2 over 4, which is a half. So there we go. That's the answer. So number 19, the answer is A. Triangle ABC has a right angle at B, and AB is equal to 1, BC equals 2. The bisector BAC meets BC at D. What is BD? Well, this question screams angle bisector theorem. And the angle bisector theorem basically states that if you have an angle that's been cut in half like this, exactly the way this question is worded, the sides create a certain relationship. And in this one, I'll just write it in terms of the letters here. BD over DC will be equal to AB over AC, like that. So this is obviously very helpful to figuring out this question. Let's label these, and you don't really have to, but I prefer labeling it X, and BC is 2, right? So that means DC is 2 minus X. And anything else that we can figure out? We can figure out AC pretty quickly, because AC, using Pythagoras, AC squared is 1 squared plus 2 squared, right? Because those sides are 1 and 2. So AC looks like it's going to be root 5. So I don't know if that's going to be helpful. It probably is. All right, so we just have to move forward with that angle bisector theorem. So BD is X, DC is 2 minus X, AB is 1, and AC is root 5. So yeah, there you go. That's the equation that you're going to use to solve for X, which is the value of BD. Cross multiplying, get root 5 X is equal to 2 minus X. Put everything on one side, and you get root 5 X plus X. Factor out the X, and you get 1 plus root 5. and that is equal to 2. So therefore x is equal to 2 over 1 plus root 5. Now that's not one of the answer choices. Why? Because they rationalize the denominator. So no problem, let's do that. So you have to multiply top and bottom by the conjugate. Is that what it's called? I think so. So this becomes 2 minus 2 root 5, and the bottom becomes 1 minus 5, which is negative 4. This becomes 2 root 5 minus 2 all over 4, and that is root 5 minus 1 over 2. And root 5 minus 1 over 2 is choice B for number 20.